to hear me, right?
Yes, we can. I think in the interest of saving the bandwidth, you can come on the audio feed, and probably while
Yes,
taking the questions, you can switch on the video back.
correct.
Yeah,
That's better
that's all.
actually.
Yeah, yep.
Yes. Okay. So good evening, everyone. So on a Friday evening, thanks for joining this particular session on an interesting topic on. We are talking about a lot of things on AI. So the topic what we have chosen for today's talk is, can AI sustain the evolution? So it looks like a very broad topic, but I don't want to leave you at a 30,000 feet giving gyan. But at the same time, what are my thoughts when we talk about this sustaining that AI evolution? Why we need to talk about that, and what are the different ways we can achieve that? So the talk is roughly around, I plan for around to speak 40 to 45 minutes. We will give option to interact as well. So out of 60 minutes, and I'll take a pause, maybe around 15-20 minutes to see if you have any specific questions on the theme, and then go into the little more details as well. So as far as the flow goes, we are going to talk on factors why we are talking about green AI. And to achieve that, we want to go deep into what are the different frameworks existing in the literature for our practice, and taking an example of computer vision, how really the optimizations can happen in the green AI space. How do you make this sustain evolution kind of aspect, taking 2-3 examples for you to convince the point. Then we were open for Q&A. If you see the AI evolution, I'm trying to start with our industry revolution. If you, as most of you know, we are in the part of fourth revolution, where people call it as Industry 4.0, and the journey started with steam power, very early days. After that, second revolution with the electricity, then third revolution. We are all enjoying it. That IT, being in IT, now the fourth revolution, AI is taking a central role. Just two quotes, right? In terms of AI is the new electricity, which is maybe this kind of a statement was made by Andrew Ng, and data is the new oil, right? So these two statements are very interesting for us to see why we are talking about it, right? So I don't really require to give what is AI and to see the evolution part of it, right? So it's not new. That AI is not new. It started in way back in 1950s, and it's going now. So, and even in the AI journey, what is the hype right now, especially machine learning, deep learning, is only a subset. Already AI at a bigger scale, it has seen AI winter twice already, right? It is trying to promise a lot of things to the industry. It is could not fulfill that for various reasons, and then it was in people call it as AI winter. Now again, with all the compute power we have, different models we have, and the data availability, for all these reasons, we are able to see good success. But the question now is, can it sustain? If we want to sustain it, what are the things we need to do? If you go the evolution part of it, I am taking this picture to convince the point very simple. First one is artificial narrow intelligence. Maybe a few years ago, or maybe tens of years ago, we are talking about machine learning being one stage in that. Deep learning is anyway a subset of it, is artificial narrow intelligence. That means we are trying to solve a specific problem, and maybe trying to complement the human intelligence. And we are going towards the artificial general intelligence. My gut feeling is we're still not there yet, but we are marching towards that. That's intelligence. What does the computer that is as smart as human across the board? That means may not be for all tasks what our human brain is capable of, but at least some certain domain, certain task, it can compete. Right? That's what the general intelligence stage what we are expecting. But down the line for our generation, it may be artificial super intelligence. That means it may compete, or even far better performance than human, right? So that is also really feasible. People say that, but it is far-fetched. Okay, but it is just a bigger goal what we see for AI 3.0 kind of a thing. But even while we are marching towards artificial general intelligence, if you see this, an interesting favorite picture for me from one rack time, my intention to you share this particular screen is to convince a point. Use of AI is everywhere now. You may be coming from education sector, you may be coming from media, you may be coming from social network defense, whatever the sector you are really representing, be it in politics for that matter, right? So the usage of AI is everywhere. Then that means you may argue it's already sustained, right? That AI usage is everywhere. Then why we are talking about can it sustain the evolution? To go to that point, or to make my point very clear, coming out of research labs as we speak in 2020 or 2021 now, we are talking about an interesting developments. One is, okay, the machine learning models exist, deep learning models exist, these are all fine. But when it comes to the latest advances to make something like, let's say, trusted AI, machine reasoning, yes, the developments are keep on going there to make good use cases or more use cases of AI. In other words, the democratization of AI is another way to look at. That means taking the business aspect of it. The people usually say it's the winner is not the guy who really have the technology only, right? It needs to solve the real business problem. Then only it can sustain. The democratization of AI is another angle on that. So apart from that, the regulations, ethics, law for AI also should be in place. Then only all the autonomous cars we talk about, or maybe the AI usage everywhere will really take into reality so that you and me can use it in the daily life. Other advancements like edge AI, and the main concentration for me on the last two topics, edge AI and green AI today, which I am trying to argue, which will play an important role to sustain the evolution of AI. You may not be convinced in the first three, four slides. Yes, we are just talking about how AI is coming so far and good. Then let me take you some interesting facts to convince my point why I'm questioning the sustainability of it. And then you can also agree to the points why that is important now and what kind of problems we can solve going forward. So you are seeing an interesting picture here. So the title says we are talking about 300k x increase in the compute in just 6 years down the line. What does that mean, right? So there are three factors I'm trying to give. First, let me address the point which is maybe evident from the picture. So if you are coming from the deep learning world or maybe solving some interesting problems, you might not have heard of all these different architectures, not to worry. But the point I'm trying to convey here is in the last 7-8 years, maybe precisely from 2012 to 18, when we solved an interesting problems using these ML, specifically deep learning, the small or a simple model of 8-layer networks from LXNet to hundreds of layer network as we speak in 2018 and 2019, see how much of petaflops per day for the training we are using. It's mind blogging, right? So it is almost like 300k x. What does that mean for us? If you see another way of representing that, the amount of compute used by these largest ML training, 2 years. Now we are talking about almost every 3.4 months, the appetite to for this compute is getting doubled, right? Can we sustain if you continue further for a few more years? May not be, right? So it's going to be the concern for us. If I translate that to what does that mean really in terms of CO2 emissions or our sustainability goals? One point in a simple way to argue there is the statistics from Google says a round trip of a fully loaded passenger jet between San Francisco and New York may release around 180 tons of CO2 emissions. If you talk about the similar one to compare one model from an OpenAI, especially GPT-3, that is for the natural language processing, which has 175 billion parameters. For training such a model, you really require 550 tons, which is 300% or 3x than the round trip journey of this. Right? That shows us in terms of how much of compute heavy these complex models are. Another interesting point for you to note down is the total electricity consumption. When you say electricity, where it is consumed, it's not really the compute power, right? As we speak now, maybe 1% of the 2020 people say. But in it is trying to help us to understand is there is a motivation for addressing this kind of a problem. That's where we are trying to say a green eye is one way. I'm not saying this is the only way to sustain it. As I already mentioned, there are a lot of other aspects in terms of sustainability, be it regulation, be it ethical, be it new technology. Along with that, green AI also going to play an important role for us. What do you mean by green AI? It's fancy to add all these adjectives to the AI, right? I might have used at least 4 or 5 here. Edge AI, trusted AI, explainable AI. Some of you heard more than this, right? But the reason to say green AI is it's not just the best model what we implement in terms of to get the better results of accuracy, but can we take energy efficiency also the primary evaluation criteria? Can we limit? Okay, so somebody says there is a network glitch. Am I clear on the audio? Is there any network glitch? Can anyone confirm?
No, it is coming good, Dr. Sunil, but however, I think there is a slight silence intermittently.
Oh, is it? Okay, let me shift the network if it any way better. Just confirm if that is better. I will shift that to.
Uh, can you still hear us?
Yeah, it is audible. Is it better now without
Yes,
any
yes,
delay?
yeah, yeah, that's
Okay,
fine.
great,
Yep.
great. If there are any issues in between also, please alert me. We can shift to other
Sure,
network.
definitely. We'll do that. Yeah.
Yeah, sorry, folks, for this glitch. Sure. What I'm trying to convey here in terms of motivation for green AI is a few questions for food for thought for us. We'll get answers for some of them here, and then some of them we can continue our research. So do we need to really train the models from scratch is one question. That means sometimes we may have something like a transfer learning, or we can learn from other existing models. So why can't we think that way? Then or accuracy or confusion matrix only the metrics if you talk about supervised learning, right? Because 90% of the problems what we are solving is that. Can we consider beyond that something like energy efficiency as a metric? How to handle return on investment? Because some of you are coming from industry, you know the importance of it. It's not just at the end only accuracy or confusion matrix or sensitivity, specificity kind of a things. At the end, we need to create or measure the impact, how much of dollar saving we have, or how much of process improvement we are able to make it, right? So, and another interesting point is target environment is different from training environment in most of the cases, right? Sometimes we may need to, we can run our models even in the mobile for inference case, right? Or even in the drones or the webcams. So we can try to see the deployment of the models there, where our training environment, we always think it's a cloud. So how to build the sustainable models in the real world, keeping that target environment in mind so that we can build the adequate models. It's not like, may not be the best model, right? If you talk about some equations on red AI, what really matters when it comes to the AI computations, right? So cost of processing depends on usually the problem to solve. Let's say regression, classification, any of those, and size of the data set. How big is the data set, right? So usually the bigger data set we will ask, because then only we can really identify the data distributions and then really identify the patterns from there, and number of hyperparameters, whether it is a deep learning or machine learning experiments. These three are important things. If you have more data, more hyperparameters, naturally the energy requirement is also huge, right? How much compute the train and inference phases demand. So we need to have a glance at that while we are talking about AI experiments. If you see in terms of how it can happen, what does that mean is, we talked about the motivators. We are convinced there may be a need for, even some of you heard of green AI for the first time, or AI evaluation in this direction for the first time, but at least we are trying to convince ourselves that yes, there is a need for this kind of an problem. So the next point is making an energy efficiency and evaluation criteria, right? Just like along with the accuracy is one easy way to start with, so that we are measuring and we are just mindful of that fact. It's not just the best model what we are talking about. Second point is on the lot of development happened in the IoT, Internet of Things, right? IoT stands for Internet of Things and AI. Can we have the convergence of that? It's not just only AI is someone says sharing the screen,
No,
stop
no,
the
this
share.
is no, no. It was all fine, Dr. Sunil. It's coming in.
Okay, okay. But you are able to see my screen, right?
Now not. I think I'm seeing a gray
I think
screen.
we are not in a position to see your screen.
I think someone
But
mentioned,
earlier
so I
it was
started.
quite good. No, no, yeah.
Okay, because someone commented that I thought the problem is from my side. So now you can see it now.
Yeah, we are on
Yeah,
the slide. How can it happen? Yeah.
yes. The same thing I'm just continuing. Yeah, thank you. So now we are talking about the AI is taking the advantage of giving us the best solutions, not just only developments happening within the AI space, the surrounding things, be it in the AR, VR, be it in the Internet of Things. We are taking the convergence of that, and then Edge AI is one such example. What do you mean by the edge, right? So the examples what we are talking about, the mobile or maybe the drone, where the real data capture is happening, can we run the models then and there itself? So that's the new way of thinking. Maybe the 5G, what we are talking about, 4G is may not be really capable to that level, but even the 5G or upcoming 6G. So you need not really think of only a cloud as even a training environment point of it as well. You can run and even train some models, maybe using latest technology, something like federated learning. On the edge network to minimize the latency and bandwidth. Sometimes suppose we are talking about security, if you want to move everything off edge, if you can make some decisions then there, we don't really require to send every data point, right, to the cloud or to the servers. So that's another advantage we are talking about it. Then democratizing the deep learning with reproducibility. Nowadays, maybe gone are the days, okay, the experiments are just within our lab, we are not publishing that. But now if you see, be it paperswithcode.com or just example one conference of NeuroIPS. So there are so many conferences are talking about, can you upload your code as well? Now it is becoming a practice. Along with the GitHub link, the people are publishing the paper. So what does that mean, or what does that mean to the literature or industry is, we can reproduce those results and can see across the domains. Also we can leverage that. That also maybe that is a result of hundreds and thousands of hours of training, right? We don't really require to start from scratch. The technique, something like transfer learning, is one such way. It is already proven well in computer vision, and now in NLP, even in other kinds of data as well, people have started using it. Then why can't we think of optimizations, both from training and inference phases? Some optimizations we can think of. So you may argue that's very standard or maybe standard research field of optimization. But what I mean by that, I'll try to explain it a little bit further. It's coming not just only from the software perspective, and we can increase from the hardware performance point of it as well. So that's also one of the key takeaway for us. So to keep that momentum further on that evaluation journey for the green AI, I'm just proposing it a different thought process for you to think in that whenever you are trying to do the experiments, the easiest way to remember is plaster plus set. So it's more like a set plaster kind of a thing, right? So it is actually an acronym carrying it out roughly 10 different uh, terminology, which is very self-explanatory. For instance, plaster stands for programmability, latency, accuracy, size of the model, throughput, energy efficiency, then R for rate of learning. This is actually coined by NVIDIA CEO maybe 3 years ago for really getting the best performance out of the model at the same time to make it sustainable, right? So I extended it further to see the maybe from the Guinea point of it, or maybe the democratization point of it, to sustain the evaluation point of it. I added 3 more terms, something like security, explainability, and training time. What does that mean? Yes, I understand what does maybe what are the basic terminology. So what? So these are just parameters or hyperparameters for me. Anyway, I'm doing to deal with our day-to-day work. But what's so special about this kind of when we say about a framework, right? So I'll try to justify that point. But what you are thinking is these are the 10 points or 10 parameters which you need to see as a data scientist. How do you make a trade-off of that? So most of you in the data science journey may agree it's not like always a best solution, right? So we can't reach anytime 100% accuracy or 100% sensitivity specificity. We always talk about some trade-offs. While talking about the trade-offs, usually people in the research talk about only at a training level. But now I'm trying to help or trying to argue here, can we think beyond the building of the model and then think of end-to-end development, deployment, and maintenance? We call it as a life cycle management kind of a thing, right? So while doing that, we may need to do the trade-offs. Maybe for a machine learning scientist or a data scientist, the moment we say trade-off, something like bias variance trade-off or maybe some parameter trade-off comes to mind. But I am trying to extend that process. On these parameters, can we think of some trade-offs? For instance, throughput versus latency. These are standard terminology. I'm not talking about I'm not defining those terminologies here in the interest of time, but these are very standard terminology. But when we talk about trade-offs, what do we mean by that? I'm trying to justify here. Let's say latency is the time between requesting something and receiving. Let's say you try to search something in Google and you are getting it, right? So the moment you are not getting within few milliseconds or seconds, right? So what you mean by that is, okay, so you are not doubting the system of the something is wrong here. I'm seeing some who is making this request annotation.
No, I think you can ignore that.
Yeah, but it is just doing it. Yeah. So the latency we are talking about, yes, requesting something and getting some response, and throughput is number of frames per, number of images or frames per second. So these are standard parameters. When we say about the trade-off, let's say the balancing between that to, let's say, the poor, to address the poor customer service or service level agreements, how do you really address that? What does that mean is latency, we can put a limit. Let's say to have good customer experience, let's say we need to present the result within 2 milliseconds. But within that limit, how many frames per second we can address that? Let's say an inference model, how many frames per second it can handle within whatever the 2 millisecond, 2 seconds, whatever the latency limit is, right? That is one kind of a trade-off. If you increase the latency limit, maybe I may need to still maximize further on the throughput, right? So there's no best solution, but it's a trade-off between them. Similarly, if you see security, explainability, and accuracy, why these two terms are related. In one angle, we are arguing our model should be secure wherever you are deploying. Maybe some places, if you are deploying really in a controlled environment of your own organization or maybe a private cloud, you will get more security by default by virtue of the system. But if you're trying to deploy your models, maybe in your edge device, in your mobile, or maybe in your base station in from a telecom point, or maybe in a healthcare point of it in your end terminal, right? So who is responsible for that security of the model? So when it comes to the security, that means we don't really require to give too many details or too many, we should not spit out too many details. But at the same time, explainability point of it, at least for the regulators or authorized users, I need to maybe open up the black box of the deep learning. So in one way, we need to, similar to the other systems, we need to, the model should be self-explainable, or if maybe some kind of surrogate models can help us to explain what is really happening so that we'll get the approvals, required approvals from the regulatory. But at the same time, when you are really deploying, you should reveal only the information which is required to secure the model. So we need to have, again, trade-off on that. At the same time, when you are trying to deploy the models in a edge devices kind of a thing, especially why we are talking about edge devices, because we can save a lot of data transfer and then compute power with that edge AI. That's a subset under the green AI. So sometimes we may not require a FP32, let's say floating point 32 kind of a precision. We can implement even at a lower precision and still do the things, right? Why can't we think of that? Always the 64-bit, 32-bit may not be really required. Similar thinking process on training time versus network complexity. As we know, both go hand in hand. If you are talking about a standard network complexity, you need more training time to really get the convergence. But why do we need to think of always the best model? Let's say some model released last month is the best model in that particular natural language processing to have the word embedding. We may be tempted to use it, but what we are arguing here is think of your application, who is going to use it, whether we really require the latest and greatest model to really solve this problem, or maybe some domain specific simplest model which may be 1/10 of the size can solve our problem. Those are the things we are arguing here. Then the last one in that one is rate of learning, then size of the model, energy efficiency, how frequently we may need to retrain, right? So that also dependent on what is the basic, whether you are following a Python stack or maybe PySpark stack, or it depends on that. Then size of the model naturally has a lot of other things in terms of number of layers, nodes, connections, all this matter in terms of the parameters, really talking about how complex our model is. Finally, what we are arguing here is energy efficiency is going to play an important role, as it is going to be a return on investment itself. Sometimes it is not visible for us because we are all doing everything in the computation in the cloud, but still overall return on investment is important because we are going to measure that in the inferences per watt, how many inferences we can do. That's going to be the measure at the end when it really solving the problems at the scale. Right. So think of these, whether all these parameters are really linked to your applications or at least some of them. Think of those trade-offs is one takeaway from this talk to achieve the sustenance of the AI evolution, at the same time green AI. Before I go to the next part of the section, because we are talking about at this stage why we are talking about sustenance of the AI evolution, why green AI is taking an important role there, I want to take a little more deeper perspective, taking computer vision as an example, and then what kind of benefit we have seen. What we are talking is not just in the air, it is really talking in the industry. We have some good examples to convey you and some open problems to work on. So let me take a pause here if there are any questions which I can take.
Well, there is one comment as such where
Yes,
the participant says, why can't we also include ML ops to the plaster set?
definitely. So when I say the end-to-end, I think the question came from the developer. Yeah. So when I say the end-to-end deployment aspect, lifecycle management aspect, yeah, ML ops, people call it as AI ops, ML ops is also part of the story, and then that also coming into the picture in this Plaster Plus set. Thanks for that one.
Yeah, thank you, sir. So apart from that comment, I don't see any
Any
more
questions so
questions
far?
in the
Yeah.
chat or the Q&A box. So I think we are good to continue.
Yeah. So I'll and then in a way we'll give about 15 minutes towards the end for
Sure.
the Q&A. So people who you can just punch in your questions, we can address whether now or maybe towards the end. The question here, since AI is applied to
Yeah.
multiple applications, can we use models across these domains? A good question, Rajshekar. So when it comes to the machine learning there, we have a lot of feature engineering maybe pertaining to that particular domain. But the beauty of deep learning at this stage, sometimes we are leaving the feature engineering also to the deep learning models, maybe at the cost of giving more data to it, right? So that way, I personally use some models. Maybe if you talk about computer vision thing, I'll show it to you in next few slides. It is possible for us to, it may be a image classification. So maybe in the literature you have a regular images, maybe in your thing you are talking about a healthcare images, or maybe a retail inside images, or maybe a telecom images, but still you don't really require to start from scratch. We can learn some best practices from there. People call it as cheat sheets because you don't really can prove that it will work and it may not work. But there are a lot of things if you in the literature which can save a couple of cycles and hundreds of hours of training for us. That's where we are talking about this green AI.
Uh, there is
Okay.
also one more question which says
Yes,
that
please.
can we also use automated AI framework to save manual training and testing time? So this is again from Mr. Rajshekar.
Yeah, that's interesting question. But if you see what is happening actually in that auto ML kind of a thing, one way it may reduce the dependency of the human, but internally it is checking multiple combinations. Maybe it is giving, or it is giving more load from the training perspective, I will say. If you, let's say, the easiest way to explain that is in auto ML, you want to see the best possible combinations of the parameters, right? If you have 4 hyperparameters, each of them having let's say 1 to 10, how many different combinations we are trying to put the load on the training. So I'm not against the auto ML kind of a thing, but if you see, if you apply your domain knowledge and able to reduce the scope of that particular, instead of 0 to 10, let's say maybe 0 to 4 or maybe 1 to 5, this may be the better range, then you are reducing those many computations and able to converge faster.
Yeah, thank you for that
Okay.
response, sir. So there is probably an interesting comment. So probably if you can share your insights on that, it says that it's interesting to know that we don't need to start from the scratch to prepare a model. So this is from Mr. Mayank.
Yeah, so we don't really require to start from prepare the model. So what I will do is I will park commenting on this. I will agree to that comment, but to justify that, maybe let's go into the second half of the session as well. And if we will address further, because some of the points are very visible here where we start and all that. Okay, then I will
Sure.
take further
Yeah.
questions towards the end. Thank you. So if you continue the session here, and there is a question on why we are calling it as a green AI. So yes, the optimizations as we see here, the green AI, the green acronym for the green is coming from the AI actually giving without our notice a huge compute at the end. The way people are coining this term green AI, just like you are seeing sustainable development goals, green everywhere, right? Can we reduce the computations required but still achieve our goal, what AI model supposed to do? That's the green AI people are using it. Okay, it's still not a very standardized term, so it's just evolving in the research and people are talking about it because if you see the journey in the last few years only, we are really going to the deployment. It just came out of the research labs and not just only limited to the Googles or Amazons of the world. Going to the real masses or democratization is happening in the last few years only. That's where the ML ops coming into picture and very recently. How do you maintain those models very recently? So it may be little early, people say that, but as we see the importance of renewable energy or maybe the sustenance of it, instead of waiting for too late, while we are talking about the models, if you adopt that, the getting the return on investment or be sustain goals of the organization is back of our mind, will help us not just only to democratize well, at the same back the best models which is required or suited for the particular situations. It may not be the best model in terms of accuracy, but we are trying to tag along that how much of energy efficient that is as well. So let me explain further using this. The key to optimize the energy efficiency is energy efficiency. We are talking in multiple phases, right? But here, when we talk about this, while you are building the model, you are talking about a lot of optimizations. Can we reduce the number of operations so as to increase the throughput? It may not happen at one shot. We may need to do lot of activities. So I'm just listing down few of them, right? Why that is important, I'll show you with one example as well. But just think of it as some of you may be familiar with some of them, but some of them it may be completely new. But just if you think in that direction, yes, it may be possible like this, right? It's not just only building the model maybe as complex as possible, but can we think of optimizing the model even which is built already, right? Suppose you some model is already in the production and running it. Is there any way to optimize it? Yes, not just only now, even the existing models also we can optimize. Why I'm saying that, I'll just give you the pointers now. But at the back end, what is happening there, instead of just showing you the results, yes, I'm able to get 10x improvement or 20x improvement, that is easy to claim. But what's happening in the back end, being engineers, it's good to see there is some kind of a quantization. What does that mean is lower precision, higher precision. I will try to simplify these things so that most of you will get what I mean by that. But if you are interested, there are complex papers for each and everything here. But the key takeaway is not to go deep dive into each of them, but to give you a perspective on, yes, these are really possible and can we really leverage both from software and hardware. That's what the aim in 15 minutes for us. Then node merging. Yes, we talk about a lot of nodes in the deep learning. So as I mentioned, we'll take the backdrop of computer vision to make my point clear. So it is really possible. One, you may start with thousands or millions of nodes, but there are ways to merge the nodes so that final model complexity will reduce. Some fusion, vertical, horizontal kind of a fusion is really possible. Then batch normalization, yes, it is really required, but in the inference space, we may not really require. Can we eliminate that once we done the real training point of it? Can we do something like a constant folding? What does that mean is some computations need to do at a compile time, some can be uh, maybe be ready during the compile time itself, right? So during the runtime, compile times, what kind of optimizations we can do there? Why it is always need to be a standard convolution? If you're coming from a convolutional neural network background, we can think of some fast convolutions. There are a lot of specific convolutions, something like a Vinograd is there. So these are just for not the exhaustiveness, but just to think through that. And then if I want to stitch together those points, how do you really see? It's not just, okay, I built whatever I want, and then towards that, I'll try to see what best I can accelerate. That's one way to do that, but that may not give us the best possible leverage. To really get that best leverage, right from the design onwards, you can do it. And people can agree, it's not like a software development kind of a thing. It's not very clear in the beginning, but yes, even in the data science life cycle, you know where to start from. As we discussed a few minutes ago, where to start. You don't really require to start from scratch. That's the start statement we made. Then where, yes, we don't really require to start from scratch, but there should be a reference model. What can be? Can it be a very base model like LXNet, what we have seen, or maybe the latest model which is fresh out of the press as of last week? No, it's not like how much old or how fresh, but in terms of seeing the exploratory data analysis, EDA, based on understanding the basic understanding of requirement of the problem, then think of the architectures which is more close to that, which is proven in the other field, right? It need not be from your own vertical. Then apply some kind of a, that may not be the best network, right? But still something like mobile net, dense net. Think what is there in the final goal as well. If the final goal is to run in a terminal, think of that. Don't take a complex model in the beginning itself, because at the end you may need to run it in a n terminal, may not be in a cloud device, right? Then there are something like a auto machine comprehension with the time and energy constraints. There are specific to your needs. There are some models, and most of them along with the code it is available. Only thing is, you should, before even start, be it in your research, be it in your industry, it's better to watch out what's there in the literature and use or leverage that. Similarly, once we build the network, so can we compress the model? Okay, maybe by pruning, maybe by quantization. So quantization we defined maybe a low precision. Okay, what do you mean? What do you mean by pruning? Okay, just maybe merging some of the nodes, kind of a thing, right? Then a knowledge distillation, maybe another kind of training examples. I'm trying to give you hints in terms of at a different stages. These can be playing important role. If you take all 3 points, then you will get the best benefit. Maybe I don't have much to do post processing, I am designing at a best level, maybe I will take the remaining thing from hardware. Fine. So based on your application, you can think of. What I'm talking on the third point is not just only software optimization. Now, be it NVIDIA, be it Intel, or maybe ARM. So these organizations are also giving us a lot of libraries based on what kind of hardware you have. The model to best perform, they are giving software libraries. Why don't you really leverage so that you don't really require to be to have unnecessary computation? You get your throughput or latency or maybe the accuracy requirements, right? So why can't we use of that? So that's the way to convey. Yeah. Convey that point. I'm taking an example which I run along with Intel during my previous organization. I want to show you the results, how you get, and what kind of things we have done. And even if you want to do now, it's not you don't to start from scratch. Those optimization. There are a lot of libraries available. I'll share the references. And mindset is because the people are missing that. To talk about that, I am taking two examples because some of you may argue if I show one result, it may be very simple, Sunil, or other may be very complex. So that's why I am taking two models. One is a simple prediction model from a bone age, and other one is a complex segmentation model. In both of them, the input is some kind of, if I'm not sure if some of you are familiar with cafe and all, don't worry about that. Let's say it's a TensorFlow or a Keras kind of a model is input, and output is actually an optimized model which is coming out, which is best suited for that hardware, because that experiment we have done with Intel, so we are using Intel OpenVINO. If you are talking about NVIDIA, if you are talking about ARM, each of them have their own respective, whatever the platform they call it as, or libraries. It's on us to really use it and get the required benefit. So just to give a glimpse of that, in terms of, let's say, inference engine from Intel OpenVINO, that's the library package from Intel. What actually it is happening is, yes, we trained a model. Maybe we already taken care of some kind of a network design optimization, post-processing and all, but still, after that, when I run that, be it a cafe model or a TensorFlow model, when I run a model optimizer, another intermediary representation, you are able to see it, right? That's where the .xml.bin are coming. Once you have that different representation, which is much optimized to run in that particular software, right? So if it is the same model, if I want to run it in a maybe in the using NVIDIA, maybe I will use their Tensor RT, right? There is an equivalent one. But the point here is you should be able to aware of that and then really use of that so that it's a benefit for the customer or maybe for us in terms of computational aspect. So to give both the examples, one example is a simple prediction model. If you see what you are seeing on the right side picture is an X-ray of the wrist. It's a simple X-ray. What it is trying to give is it will tell the bone age, as the name indicates. It may be less than the actual age or it may be equal to the actual age. What is the use of that? If the predicted age is less than the actual age, that means there is some kind of a malnutrition. Maybe in the sports people can use it as well, whether they are really giving whether it is because of the malnutrition or maybe they are understating their age, right? There are multiple uses of that depending on where you are using it. Why people are interested in that? Maybe age assessment, as I mentioned, by sports authorities, or improved productivity of the radiologists. Here we are not trying to replace the radiologists. How can we help them by using this prediction model, in which case to identify clearly, let's say predicted age is less than actual age. Okay, so that is one model. Looks like a simple classification model, right? Or you can think of a simple regression model, and where we have we use some kind of a XNet to start with, and then develop a model. Another complex model is on the lung segmentation. What does that mean is, as you know, segmentation is a little more complex. That means each and every, it's more like a pixel level classification to identify the lungs, right? So maybe we may need to use these CT scans, right? For lungs. Now we are talking about the CT scans and lungs in the COVID-19. The number of people who are taking is very much, right? So to identify, let's say, COVID, or maybe previously we are talking about TB, there are a lot of data available now. Uh, Segment it and see how much of issue or abnormality is there. Maybe we may need to build a different model for COVID-19. But this is the we tried that in the models, segmentation is kind of network of a unit architecture. My aim here is not to just go walk you through the architecture, but to show you the complexity of it. Okay. Ignore the other DLDT, MKLD. These are different libraries from Intel, not to worry on those. But when we are talking about the optimization, we are talking about, yes, we can reduce the layers by fusion. And more interesting point is to present you the results, and all the background in the last 5-10 minutes is to convince you where from that results are coming. If you see what is the result here, how many frames per second I can process. What does that mean is, yes, I have a model which is built both for a prediction model and a segmentation model. And in a regular machine, Intel machine, I can process not even 2 images per second. That means I can put a scan, be it an X-ray scan, CT scan. It takes some time to the result. Not more than 2 images or frames per second I can process. But the moment I use Intel OpenVINO, I'm able to maybe if in a simple case, simple model up to 30x. That means 30 times more, roughly 70 plus images I'm able to process it in this using the same machine. And in the other case, maybe 7 times because it's a complex model. Similarly, the last one is if you have multiple instances of it, if you really need of that, then there is much more optimizations can really possible. Right. So what I'm trying to convey here, there is a report also, if you are really interested, is what we are talking here in terms of software and hardware optimization, a journey towards green AI, not just in the research only. We are talking about real implementations where the optimizations are coming from these. So you don't really require to the beauty of that is these are the things also you can plug and play and choose from the libraries given by these hardware players. So to summarize those points, we have all these custom hardwares and we may need to run our deep learning or machine learning models in any of those, be it in a simple neural stack or maybe Google Edge TPU or any of the, even in our mobiles, these processors, right? When we are trying to conclude that and before opening up the questions, the last few points, what I'm trying to convey here is from the view of developers. Yes, we understand the bigger picture. There is a need for AI evolution to sustain it. Maybe green AI is one such way. Then what I can do as a developer, just being aware of that Plaster Plus framework for trade-offs, at the same time, being aware of different compute intensive platforms. It's not just only the cloud or your machine what you have. In the cloud, yes, you may have Google Cloud, Amazon, or Azure. That is one way to look at. In the mobile also, you have a lot of these TensorFlow Lite version, PyTorch mobile version, or Open Neural Network Exchange. Okay, so there are a lot of development happening at a mobile and even at a tiny level, at an edge device level as well. Even Raspberry Pi, IoT, Arduino, they are also giving us a lot of libraries which we can reuse and contribute towards that. Right? So to summarize the key takeaways and where we started with, we trying to give you the AI evolution, why that is important, and then trying to establish the need for green AI. To redefine what is green AI is not just only the simple metrics like accuracy, keep that energy efficiency also in place in your evaluation metrics, because that is the key. And we all agree that it's going in multiple iterations to really achieve that goal. To achieve those goals, we suggested there is a framework which can help you out on what trade-offs which are important for our application or our scenario, our domain, and then optimization using not just only software. You can see how much of optimization from hardware also we can leverage. And nowadays, to just give an example, these results, what I have shown it to you, when we really worked, it took a couple of months for us to reach there, because those are beta versions maybe 2-3 years ago. But now within 2-3 hours, you are able to, using those libraries, you are able to run your own models. That simple, simplified those packages are. So only thing is we need to be aware of what's going on and then contribute to the bigger aim for us. With a lot of references for that, and then I can share you those. Let me take a pause here and then open questions. I see a lot of questions from the chat, and over to you, Changappa, in terms of whether we want to take from chat or maybe
Sure,
somebody
sure.
opens
Yeah.
up.
No, we will probably first address the questions from chat from where we left. Mr. Pandu wants to probably get your insights on why we are calling this as a green AI.
Mhm. Green AI is the term to make sure it's not just a simple definition of it, but all the efforts which can contribute to give the energy efficient, build the energy efficient models, AI models, right? All that you can put under the green AI. Okay, or people can going forward get it into sustainable AI, right? This still not those terms are not really standardized yet. But the moment we say sustainable AI or green AI, all the efforts from the developers, keeping in mind not just only the end goal as accuracy or how best the model is performing, but keeping an eye or an evaluation metric under the energy efficiency point of it, all that efforts will go into the green AI. So he says, right from business strategy, business execution, technical agent, can you explain? Yes, it is there from the business strategy and execution point of it. What matters for us is if you are having low compute, it is indirectly helping the organization first. Maybe the bigger goal, it is helping the society, sustainable planet and all. But even in the beginning, yes, I'm not spending too much time on my, let's say too much dollar value on the AWS bill at the end of the month, but still achieve my building of the models. Yes,
Yeah,
I
thank
can
you
go to
for
the
that response,
links.
sir. So I think probably you can flash the reference slide. So as we take questions,
Yes,
people can also refer that. So the
sure.
next question is from Mr. Deepak, where he says that its cognitive decisions are optimized on real-time AI. So your insights on this.
Which question is that? Am I going up? There are a lot of interesting
Uh,
looks like, but
that's
which is
right.
this?
So I am just sharing this on your chat, so you can refer that.
So EDG, cognitive decisions are optimized on real time. Yeah. What is that EDG?
I'm not sure. I think that it could be Edge. But
Okay, edge
it
cognitive
is.
decisions are optimized on
Yeah.
real-time AI. Yes, that's actually the new ways of, let's say, federated learning or maybe the edge AI aspects. Mostly, as of now, we are using it for inference level, but sometimes it can even contribute to the federated learning point of it. That means we are making the decisions. Yes.
The next question is from Mr. Sai Krishna, who wants to know that do you think real-time or incremental training of models in production will help in saving training phase computations?
Real-time training of model production will help in saving training. That's a catch, Sai, there. The point is, unless we have some kind of testing, right, in the we go to the real-time incremental training. So in the case, it may not really possible, but then if we already develop a model, you know how the data distributions are, you know the real parameters to handle. In those cases, yes, you can go for the incremental training. I agree, but at least the base model initially should be able to solve our basic requirements. Then we'll talk about the incremental thing that can happen, that retraining kind of a things, right? That concept drift retraining, those can things can happen in production. Everything you need not start from scratch. Yeah.
Yeah, so probably there is a different perspective for the next question. Mr. Setu wants to know your thoughts on how AI and quantum computing are going to evolve in future. Will it be a supportive coexistence or two separate evolutionary streams?
Okay, so for me, as I mentioned to you, Setu, right? Even that as of now, Internet of Things, then AR, VR, or even autonomous cars, and a lot of development and other things, they are complementing each other. So I will make one statement. So initially, before the AI journey, I am part of Internet of Things. That time, the term 15 years ago is not even that popular as well. So we have a lot of hype that IoT will change the world, and MIT has a project, something like a smart. Within 10 years, what does that mean is it will go into the, as the IoT devices will go as small as the dust particles and it will be pervasive everywhere. That's 15 years ago. But have we reached to that level as we speak now? Not really. but doesn't mean that IoT is a failure, right? But the hype was little more than the reality. And we have seen a lot of technology is good, but return on investment is a problem. Then AI is coming as a savior. For AI, we need the data. That's where the IoT devices are giving. At the same time, for IoT, to get the business justification, we need the return on investments. Okay, we are collecting the data for what? So I'm investing something. Can the decision making, identifying the patterns, can save me in turn both in long term or maybe as short term? So can I get the benefit within, let's say, 2 years, 3 years? That way, going hand in hand. By taking that example, even my gut feeling is both quantum computing and AI can go together. How that quantum computing can help in the green AI is an interesting research area, because both of them are new. But because we are talking about now the hardware aspects which are available right now with Intel or NVIDIA, but the moment the quantum computing comes, you are able to do a lot of computations within a fraction of present time, right? So that way it can definitely contribute to the green AI perspective. And my feeling says it can complement and the AI evolution journey.
Yeah, again, with response to that answer, so we have an interesting comment here from Mr. Rao, who says that
Mm,
quantum computing would definitely be going to be the fulcrum of future AI development. So
correct.
only time can answer that. As you rightly mentioned, that we are too early for to probably at this stage of things. So the next
Correct.
question is from Mr. Rajshekhar. The question goes like this. There is a myth that more complex the model, more accurate it is. Is that right? And
Mm.
how to break that? For example, more no on convolution layers in CNN, better
For
for
computer vision processing, yeah.
vision processing.
So more number of convolution layers. Yes, a good question, Rajshekhar. So what we see now, maybe initially 2 years ago, I will give my personal example. I might have boasted, okay, we executed a segmentation model of brain segmentation for with the 318 layers. That's a complex model I worked on, and which takes tens of hours to really converge as well, right? In the initial days, it's maybe a weekend or even more than that to just to converge one iteration, one complete set, right? In terms of epochs to converge. But now, the point, as you are mentioning, the more complex may not be always more accurate, because the recent developments, be it ResNet, be it because they are talking about skip connections, optimizations at different levels. There are a lot of innovations in last few years. Always the more complex need not be, but at the same time, if you start with a gigantic network of 100-layer network, it will be difficult for you to really optimize. So what we recommend even in the real doesn't mean that you need to start with very basic thing, but based on your need, maybe net or a dense net, which is not very complex of the state of the art, but still it is decent enough for you, a ResNet kind of a thing with a 50-layer network kind of a thing, which can really solve your problem. Once you identify it, there are a lot of explainable AI things. That means what is actually happening within the layers. So it's not like blindly you are checking some model and then you are getting some results initially, but to tune it, you can take the latest advances, something like explainable AI, so that what really happening in the network, can I reduce the, let's say, filters or increase the filters, those things you can do that. That way you are able to make the model more sustainable as well.
Yeah, thank you, sir. So we are already on top of the hour, so I think we still can accommodate a couple of
Yeah,
more questions, if it is
sure.
okay with you. Yeah, okay.
I'm
So,
okay as long as
yeah,
or let me do one thing. So let's formally close if some people have maybe an appointment right after this. So let's formally close it, and then still we will address these questions. So thanks
um,
all of you for joining.
right.
And then if you have further things, so please connect us through IEEE, or I shared my LinkedIn as well. So if you have some interesting thoughts, feel free
Right,
to
and
float
again,
in those.
the recordings of this session would be uploaded on our IEEE Bangalore section YouTube channel, so you can also refer back to that link to get the insights for today's session. So yeah, so to continue with the questions, the next question is from Mr. Divakar Das, who wants to probably know that think
Is it this one? Are
yeah,
there any data on the
correct,
power
yeah, this is
consumption
it,
of the
right.
custom hardware? from the vendors versus different types of applications.
Right.
If you, yes, Debakar. So I shared you one report where I worked personally, that is just maybe 2 years ago. After that, I'm sure if you just type, let's say I'm typing it for you, Tensor RT or Intel OpenVINO, there are a lot of case studies which they will help you out, and whichever is closer to you, you can take a look at that. Right? We addressed this.
Okay, so okay, so probably some advice Mr. Mayank is looking into.
Mm-hmm.
So he's an infrastructure architect, currently doing that role,
Mm-hmm.
and he want to learn and move forward in AI. And what do you typically recommend to for someone to begin with having that
Okay.
exposure to the infrastructure and then
So is it
wants to
Mayank? Is it computational infrastructure architect? If is a data architect or maybe
Hi,
computation?
Mayank here. I hope I
Yeah, I
can
mean,
hear
yeah,
you.
we can hear you.
Thank you so much. So primarily, I'm an architect in terms of infrastructure towards your server, compute, storage,
Okay,
and
got it, got
provide
it.
service to
Yeah.
the customers. Thank you.
Yeah, that's an interesting role. So if you want to really use the thing, right, common applications of AI where we see that for that journey, right, using it for prediction. So you may already have a lot of static things in your case. Let's say some server is 60% fill in the CPU, 60% or maybe 90% in memory. You will get a lot of these kind of alerts, and but the AI can play the role in what alerts really taking the real-time situation in mind. Maybe some bad jobs are going to run because it's a weekend or month end. It's not just a static thing, but keeping what kind of jobs it may come upfront as well. Can it make a wider decisions instead of 1,000 alerts for you, which you need to act on? Can it customize and able to give you only, let's say, 100 alerts, maybe 90% of them is taken away from your kitty, right? So that's where the standard application of AI comes. But when it comes to the green AI part, the infrastructure point is very important. So how much to run where? Suppose if you have infrastructure in spread across, not just only let's say in India, maybe you have infrastructure to run these models in US or in Europe, in Australia, in India, because the energy requirements from there also is not exactly the same, right? Maybe Europe may say 50% of my energy is renewable. Okay, and we are still not at that level. So people argue, there are interesting papers from Nature as well. That first link also you can see there, maybe link also you can see there. They are also trying to give is where to run your particular requirement. That also really matters and contribute to the green AI aspect. So think of those, and then if you are really interested to build the models and if you want to taste the data science aspect, there are a lot of material in open source, be it in analytics Vidya, be it in analytics India magazine. So a lot of free courses are also available, but if you want to really come and join, there are structured courses in Coursera or maybe in a lot of learning from the paid versus free.
Yeah, thank you, Dr.
Thanks
Sunil,
so much.
for that answer. So the next question is from Mr. Sanjay, who wants to know that in telecom and precisely 5G, what is the current use case where we
Yeah.
can monetize using AI and ML?
Correct. In telecom 5G, what is the current use case? Yeah, there are a lot of use cases we are talking about. So let's say 5G deployments in India, it's still not there, but we are able to, I think, as of last quarter, we are able to sign more than 100 contracts from our organization point of it. We are still getting those initial data points. So the way what we are looking there in terms of latency, throughput, predicting the issues upfront, those are not much different. Only thing is that 5G KPIs or maybe 5G in structure point of it may be a little different compared to 3G and 4G. But apart from the benefits what is going to offer, right? Good throughput and ultra low latency. But from the AI ML point of it, really the similar problems what trying to solve in the 5G as well. And if you see the latest developments are not, while 5G is getting rolled out, which may take few years across the across the globe, even 6G also people are talking about, where the 6G is AI itself is a foundational thing, which is baked in right from the physical layer till the application layer. But in case of 5G, both a good combination of AI ML plus 5G, the applications of telemedicine or real-time gaming, which are not really possible at a 4G level. So those are the things which we are talking about as giving that real-time examples is a good usage of AI plus 5G. But inside the 5G to use it, the typical applications of prediction and all also we are doing it. Two aspects I mentioned.
So the next question is from Mr. Sachin, who wants to know that are there any limitations on application of AI from human body perspectives?
There is no limitations per se. Okay, can you repeat the?
Are there uh, are there any limitations on application of AI from human
Okay.
body perspectives?
Are there any limitations on applications of AI from human body perspective? Sachin, I don't really see. But if you see, Internet of Senses people are talking about now. So we already have 5 senses, right? So right now we are seeing only not all 5 senses are really internet enabled. Mainly the hearing and maybe viewing is that, but smell, touch, and all that we are still not able to see that. So that's the new thing people are talking about, Internet of Senses. But I don't see really the limitation point of it. But if you're interested, just type in internet. I mean, Google it. You will get some references from Ericsson, even on the other side as well. Internet of Senses. Right.
So I think probably this would be the last question.
I get one more where I can get the complete information about CNN. I'm new to CNN. I'm learned to part of CNN as part of it. There's a lot of information. So such so interview. If you just are convolutional neural network, there are interesting blogs and then survey papers. This a well researched topic. You will get it. If you have any struggle on that, just ping me in LinkedIn. I'll give you.
Yeah,
So I
the
think we
next
covered
question.
most of them.
No,
Yeah.
last question, I think, from the general pool. Mr. Kaushik wants to know that in the context of today's topic of green AI, do you think
Mhm.
a low-code application like Oracle Apex or an autonomous database will help in
Mhm.
agile development of a data-driven application, which is need of the hour today?
Yes, so I will. I haven't still personally tested that, let's say, Oracle Apex per se, but definitely, if you are able to achieve something without much computational effort, we are able to achieve it. All that will contribute towards the green AI efforts. So it's not like whatever I've given you as a backdrop of computer vision, one thinking process. If you have, definitely based on your background, some of you are coming from infrastructure background, some of you are coming from databases, data mining, wherever you see the value of it without burning a lot of this carbon at the end, right? So the whatever the effort we can make to make it more energy efficient in such a way that we are able to contribute to the sustainable AI is definitely valuable. Yeah,
Yeah,
I think
thank
after
you,
that all
Dr.
that
Sunil.
comment.
I think, yeah, we have covered most of the questions. And again, going by the comments from most of the participants, thank you for the insightful and informative session and where we are headed with Green AI. And once again, for all the participants who are still with us, I'm just sharing the link of the IEEE Bangalore section YouTube channel as well, where this session would be posted in a couple of days. Yeah, I think it's time now to formally end the session. Yeah,
Yeah.
so going by the theme of today, keep training, keep learning until you get it right, and until we meet again, stay safe. Yeah, and definitely, if there is anything more, you can definitely reach out to us on email, and we would be happy to assist you with that.
Yeah. Thanks, Chingappa, and thanks for the opportunity. All the very best to all the participants, and welcome to the AI world to solve interesting problems in real world. Thank you.